In the tapestry of our planet's history, few phenomena have held the same level of fascination, fear, and scientific intrigue as volcanoes. These awe-inspiring geological wonders serve as both a testament to the raw power of nature and a stark reminder of the forces that have shaped and continue to shape our world. From the fiery depths of the Earth's core to the dramatic spectacle of an eruption, volcanoes captivate our imagination and drive our quest for understanding. But what exactly are volcanoes? What drives their formation? And what makes them such powerful forces of nature? Join us as we take a deep dive into the science, history, and cultural significance of volcanoes. We'll explore how they are formed, the different types of volcanic eruptions, and the impact they have on our planet and its inhabitants. Whether you're a science enthusiast or just someone who's ever been awestruck by the power of a volcanic eruption, this is a journey you won't want to miss. Volcanoes, the Earth's fiery giants. Our planet is a dynamic and ever-changing entity, and at its heart lies a core of immense heat and pressure. This internal energy is the driving force behind many of the Earth's most captivating features, including volcanoes. But what exactly causes these towering structures to form, and what makes them such powerful geological entities? To understand volcanoes, we need to delve deep into the Earth's structure. Beneath the Earth's crust, there's a layer known as the mantle. The mantle is not a uniform entity, but rather has distinct regions based on temperature and pressure. The upper part of the mantle, along with the crust, forms the lithosphere, which is divided into tectonic plates that constantly interact with each other. When these plates converge and one begins to subduct or move beneath another, it sets in motion a series of events that can culminate in the formation of a volcano. As the subducting plate descends into the Earth's interior, the intense heat and pressure cause the release of water and other volatile substances. These materials rise through the mantle, creating pockets of molten rock known as magma. The magma, being less dense than the surrounding mantle, gradually makes its way to the Earth's surface. As it approaches the surface, it may collect in chambers beneath the Earth's crust, slowly pushing up and creating bulges. Over time, if the magma continues to accumulate and the bulge becomes too great, the overlying crust may rupture, providing an opening for the magma to escape. This eruption is what we typically associate with the volcanic activity, giving birth to a new landform that we call a volcano. Anatomy of a volcano. Once formed, a volcano is composed of several key parts, each contributing to its overall structure and function. At its core, we have the magma chamber, a reservoir of molten rock that fuels the volcano's eruption. The shape of the magma chamber can vary depending on various factors, but it's often irregular due to the complex dynamics of magma movement. Above the magma chamber is the volcanic neck, the region where the magma makes its final ascent before eruption. This part of the volcano is crucial, as it acts as the conduit through which the magma is forcefully expelled during an eruption. Extending outward from the central vent or opening of the volcano is the cone. The cone is formed by the accumulation of volcanic materials such as ash, cinders, and lava that are ejected during eruptions. The angle of the cone's slope depends on the type of material and the viscosity of the magma. The external shape of the volcano is not just a matter of aesthetics, but is a testament to the internal processes occurring within. Each layer of volcanic material tells a story of the forces that shaped it, making the volcano's structure a sort of geological diary. Types of volcanic eruptions. Volcanic eruptions, while sharing commonalities, are far from being a uniform experience. Different volcanoes exhibit different characteristics during eruption, making each event unique. Broadly, volcanic eruptions can be classified into two main types: explosive and effusive. Explosive eruptions are characterized by a sudden and violent release of energy, often accompanied by the formation of vast ash clouds and the ejection of volcanic matter over large distances. These eruptions are typically associated with highly viscous magma that contains a high concentration of gas. As the gas-filled magma ascends, the decrease in pressure causes the gases to expand rapidly. This expansion generates tremendous pressure that, when released, results in a powerful explosion. On the other hand, effusive eruptions are marked by a relatively calm and gentle outpouring of lava. These eruptions occur when the magma is less viscous and has a lower gas content, allowing the lava to flow more readily. Effusive eruptions are often associated with the formation of lava lakes or the slow-moving lava flows. It's important to note that these categories aren't absolute, and many eruptions display characteristics of both types. For example, Mount St. Helens, known for its devastating 1980 eruption, had a relatively small but extremely explosive blast. In contrast, Kilauea in Hawaii is famous for its effusive eruptions, which have produced vast lava lakes and have been the subject of extensive scientific study. Volcanoes. Destructive forces of nature. The power of volcanoes is undeniable, capable of reshaping landscapes and impacting life in profound ways. Their influence extends beyond the immediate vicinity of their vents, affecting the Earth's atmosphere, climate, and even the course of human history. During an eruption, volcanoes release a variety of gases and particulates into the atmosphere. These emissions not only include water vapor, but also carbon dioxide, sulfur dioxide, and ash. These gases can have a significant impact on the Earth's atmosphere, leading to changes in global climate patterns. For instance, the massive eruption of Mount Pinatubo in the Philippines in 1991 injected enormous amounts of sulfur dioxide into the stratosphere. This led to a global cooling effect, altering weather patterns and contributing to a slight drop in global temperatures. Volcanic eruptions can also trigger other natural hazards, such as lahars. Lahars are volcanic mudflows that consist of a mixture of volcanic debris and water. They can be triggered by heavy rainfall, melting snow, or the overflow of a crater lake. Lahars can travel at high speeds down river valleys, causing widespread devastation. Additionally, volcanoes can pose a threat through the release of volcanic gases. Gases like carbon dioxide and sulfur dioxide can be toxic and pose risks to human health. In areas surrounding active volcanoes, there's always a potential for gas-related hazards, underlining the importance of monitoring volcanic activity, a legacy etched in stone and fire. Throughout history, volcanoes have been more than just geological phenomena. They've been witnesses to, and sometimes participants in, the grand drama of human history. From the awe-inspired myths of ancient cultures to the scientific scrutiny of modern researchers, volcanoes have held a prominent place in our collective consciousness. Ancient civilizations often attributed supernatural powers to volcanoes, weaving them into their myths and legends. For example, the Romans believed that Mount Vesuvius, which famously destroyed Pompeii, was the home of the god Vulcan. Such beliefs were not merely a product of ignorance, but represented an attempt to comprehend and respect the awesome power of these natural wonders. As societies progressed, volcanoes became key players in shaping human settlements. Cities like Pompeii and Herculaneum, nestled in the shadow of Vesuvius, flourished due to the fertile volcanic soil, only to be tragically erased by the very same soil's fiery temperament. Even today, many major cities like Naples, Tokyo, and Manila are situated near volcanoes, highlighting the enduring human fascination with these volatile giants. Scientifically, volcanoes have provided invaluable insights into the Earth's inner workings. By studying volcanoes, scientists gain a deeper understanding of the Earth's internal structure, the dynamics of plate tectonics, and the processes that shape our planet. The analysis of volcanic activity helps predict future eruptions, giving scientists and communities valuable time to prepare and mitigate the risks. Places like the Ring of Fire, an area around the Pacific Ocean with high volcanic and earthquake activity, are not only seats of both wonder and peril, but also key locations for geological research. Conclusion: even with the giants, our relationship with volcanoes is a complex one, marked by both fascination and fear. These fiery earthshapers have the power to alter landscapes, economies, and even the course of human history. As we continue to study and explore volcanoes, we gain not only knowledge about our planet's inner workings, but also a deeper appreciation for the forces that have shaped and continue to shape our world. Understanding the science behind volcanic eruptions allows us to better predict and prepare for potential hazards, mitigating the risks and protecting lives and property. Furthermore, advancements in technology such as remote sensing and real-time monitoring have greatly enhanced our ability to observe and analyze volcanic activity. These tools provide invaluable data, enabling scientists to issue timely warnings and helping communities to make informed decisions during an eruption. Volcanoes stand as powerful reminders of the dynamic forces that shape our planet. Their eruptions, while destructive, are also a testament to the Earth's incredible power and adaptability. As we learn more about these fiery giants, we not only unravel the mysteries of our planet, but also gain insights into our own history and our place in the grand tapestry of the Earth's story.